I am HR Krishnamurthy. I am currently a retired professor at the Indian Institute of Science Physics Department. I and my colleagues in India and in IISc and in France, we had a CEFIPRA project from 2002 to 2004. From the Indian side, the co-principal investigators were myself and Professor B. Sriram Shastri, who is no longer here. He has moved away as a professor and he's currently a professor in the University of California in Santa Cruz. From the French side, the principal investigator was Professor Antoine, who was at that time professor in Ecole Normale Supérieure, and he has since moved as a chair professor in condensed matter physics in Collège de France, and he also has joint appointments in the University of Geneva and Ecole Polytechnique, and he is also the director of the Center for Computational Quantum Physics and the Flatiron Institute in New York City. The other co-PI from the French side was Professor Roderick Mosna, who used to be in ENS at that time, but is since moved to the Max Planck Institute for Complex Systems in Dresden, where he is the director of the condensed matter division. Two other people that were involved in this project were Dr. Olivier Sepa, who's a French postdoctoral fellow who spent 1 year with a 3-month break in India from 15 September 2002, and my former student, Dr. Syed Raghib Hassan, who spent a little more than a year as a postdoctoral fellow working with Professor Antoine in France. So our project was titled "The Study of Strongly Correlated Electron Systems." So its main aim was the study of theoretical understanding of materials where electron-electron interactions are very strong, and this is actually a major frontier area of modern condensed matter physics. So it includes very many exotic materials such as high temperature superconductors and what are called cuprate materials, and MOT, metal insulator transition, materials called manganites, which show some property called colossal magnetoresistance, frustrated magnetic systems, etc. So there are a host of materials which are in this category. So we wanted to explore many of these materials from using theoretical models and try to invent new approximation methods for solving them, because basically the problems are extremely complicated and challenging and you cannot solve them exactly. So we wanted to explore various approximate methods of solving them, and in particular one method called dynamical mean field theory, which had been invented just a few years prior to our project. So quite a bit of our work is using this method. I won't have time to talk about all the different papers that came out of this collaboration. I'll just mention one or two. During this period, actually, along with a colleague of mine, Professor T.V. Ramakrishnan, who was not formally part of the project, and the student of mine whom I mentioned, whose name I mentioned before, Syed Ragib Hassan, and another student, we actually invented a new theory for this material item I mentioned earlier called manganites, which show colossal magnetoresistance. And it explains many properties of this material in terms of a new model, which is then again hard to solve, but which is then solved using dynamical mean field theory. And the French postdoc who came here, Dr. Olivier Sepa, actually worked on developing this theory further for other regimes of doping of these manganites. So that whole set of work was quite a nice success story of projects that benefited from the support from CEFIPRA. The support from CEFIPRA was extraordinarily valuable for us during this period. Apart from the postdoc exchange, which I have already talked about, I made 4 one-month visits to École Normale Supérieure and interacted with Antoine George. And Professor Roderick Mosner made a visit to IFC and spent some time, and the collaborations that started at that time actually continue to this day, in not directly with us, but with other students that came into contact with these scientists at that time.
Long live India and France friendship.